Having multiple coordinate systems, we'd like to be able to convert between the two. Like given an equation that's in rectangular form, can we write it in polar form and vice versa? So this is actually pretty straightforward. What I'm going to do here is I'm going to first just line up the two systems on top of each other. So here's my rectangular system, and then I'm going to place the pole right at the origin. Okay, and then of course the polar axis corresponds to the positive x-axis. So now any point that I have, well, we know that we can represent a point with x, y, and that means that this distance, this horizontal distance, is x, and this vertical distance is y. But I can also represent this point as r theta, where r is the distance from the pole to the point, and theta is that angle. So now, hopefully we can see that we've got now just a triangle with some side lengths of x, y, hypotenuse of r, and this angle of theta. So that tells us how to get our conversions. If we look at the cosine of the angle theta, cosine is adjacent over hypotenuse, which is x over r. So we could solve for x and get x is equal to r times the cosine of theta. We can do something similar with the sine. Sine of theta is equal to y over r. And solving for y, we get y equals r times sine of theta. So these are kind of the two main conversions that are used to go between polar and rectangular coordinates. Another one that's pretty common and useful is the Pythagorean theorem. X squared plus y squared is equal to r squared. And another, the last one that I'm going to talk about is if we look at the tangent of theta, which is going to be y over x, right? Opposite over adjacent. So y over x is equal to tangent of theta. So these are the most commonly used conversions between polar and rectangular coordinates.